Hey guys, this is going to be Stats Day 2. So this is going to focus on statistical studies and sampling methods. Okay, so there are three main types of studies that we can do. So the first is a sample survey, and it's just a survey. So it's where you're asking every member of the sample the same set of questions, and then you're recording the answers. So an example of that would be a survey on which political candidate you prefer. An experiment is just like an experiment you would do in science. You apply a treatment to some group and measure the effects of the treatment. So an example of that would be testing the effectiveness of a new blood pressure medication. And then the third is an observational study. You're observing. So you observe members of a sample in a way that they are not affected by the study. So you could say a study on how many shoppers are using reusable bags. So you're just at the store looking at how many people are using reusable bags. You're not interfering in any way. Okay, so now we're going to talk about bias. So a study has bias if it systemically produces results that misinterpret a population. So you guys know what bias is. It's a way that you can either ask questions or the way that you're getting your information where it's creating something that's not really true. So an example here would be a psychologist is conducting surveys to study the happiness levels of people who live in a neighborhood. She asked the same question to the two samples below, chosen from the population of the neighborhood. So she has 100 people that were surveyed on a sunny Saturday, and 65% of them said that they were happy. And then she had 100 people that she surveyed on a Monday morning, and 35% of them said they were happy. So the bias there is when she's asking these people, because if you're out and about on a Saturday and it's super nice outside, you're probably going to say that you're happy. Obviously, that has a higher number than on Monday morning when you have to go back to work. You're probably going to be a little less happy than you were on Saturday. So the timing of that created a bias there. So you have to, when you're doing statistical studies, you have to make sure that you're trying to get rid of as much bias as possible, because you're trying to figure out the real results there. You're trying to figure out, for this psychologist, he's trying to figure out what is the actual happiness level of these people. And if you're getting a huge range of 65% this day and 35% this day, you don't really know what that means. You want to try to get as accurate results as possible, so you have to look out for that bias there. So here's another example. So in the following situation, are there differences between groups potentially due to bias? So we have a school wants to know the average height of its students. The school randomly chooses some students and measures their heights. Some students are under 5 feet tall and some are over 6 feet 5 inches tall. So the fact that some of the data collected here is either very high or very low is not necessarily the result of bias. So we said in the last example, it was because they were very different because of when she was asking it. But a population like students in a high school will naturally have people with a wide variety of heights. So in school, you have some people who are short, you have some people that are very tall. So that's not necessarily biased, that's just how heights work. So a true random sample may have members from both extremes. If you're randomly picking people, there's probably going to be some short people and there's going to be some tall people. So if the school chose only basketball players who are usually taller, then that would be a biased sample, because then you're taking only the tall people and measuring them. Okay, so try to think of the difference there. Is it just because that's how things are? Like, it's just because heights are very different. You can have very short or very tall people, or are they intentionally like picking people who are going to be very tall or very short? Okay, so here's some different types of bias that you can have in a survey or in a study. So you can have leading questions, and that's exactly what it sounds like. You're leading someone to an answer that you want. So a question like that would be, wouldn't it be so much better if we were able to leave campus to go and get lunch? And you're leading people to say, oh yeah, of course, that would be so much better. A way that you would ask that is, that would be not leading, would be, do you think we should be allowed to leave campus to get lunch? And then it's like, yes, no, either way is fine. But if you phrase it as, wouldn't it be so much better? You're putting your opinion into that question and you're saying, you should agree with me. The next one is non-response, and that's people not responding. So if you have only 10 people out of 1,000 that were asked and answered the survey question, that is not enough people. That's only 1% of people there that are answering that. So you don't have enough information. You need to get more people to answer your survey. For voluntary response, you're only asking for volunteers to answer a survey. So think about those surveys you get on receipts when you buy things from like Walmart or Target or whatever. Those are only voluntary response, right? You don't have to do those. The people who are going to answer those surveys are usually people who had a great experience or who had a terrible experience and they want to share it with the company. So for those, you're going to get very extremes. You're not having the person who just went in, got their groceries, and they were good. So that would be voluntary response. You're only asking for people to answer it. Or if you're asking something about, let's say, your average salary, right? How much money are you making? You're probably only going to have the people who are getting a lot of money answering that question. So the voluntary response is not great. You want to try to get a random assortment of people just because the type of people who are going to answer that survey are probably only going to be thinking in one way. And the next one is selection bias or convenience sample. So you're only asking people at the movies if they like going to the movies. Okay, so that's convenient, right? I'm asking people here if they like this thing, or I'm selecting these people to answer my question. Because if you're out at the movies, you probably like going to the movies. Okay, if you randomly ask people just like at a grocery store or out on the street, if you're asking them if they like movies, that's not going to cause a bias. But if you're at the movies, people probably like the movies. Okay, now we're going to talk about sampling methods. So in order to select a sample that is likely to be representative of the population, you need to choose members of the sample using randomness. You need to be as random as possible. So the simplest way to use randomness is with a simple random sample. In a simple random sample, each member of the population is equally likely to be chosen, and each possible sample of the size you want is equally likely to be chosen. So some sampling methods can involve randomness and other ways to select a sample. Some sampling methods do not use enough randomness to give reliable results. So sampling methods are, how am I picking the people that I want for this experiment or for this observational study or for this this survey, right? So there's a couple different ways that you can pick people. And some of them are more random than others. Some of them are more reliable than others. So here are the types of sampling. So on the left, the three on the left, stratified, cluster, and systematic. Those three are good to use, but you still need to make sure that you're avoiding bias. On the right, those two, the convenience and the self-selected, those have a very high risk of bias and you should not be using them if you want to be as random as possible. So stratified sampling is when a population is divided into groups with similar characteristics and a sample is chosen randomly from each group. So if we're talking about high school, I would split you guys into grades. So I have 9th grade, 10th grade, 11th grade, 12th grade. And then I'm choosing randomly from each group. So I pick like 10 from each grade, and that would be stratified. Cluster sampling is when a population is divided into convenient clusters and entire clusters are chosen at random as a sample. So if we stick with the same example with high school, it would be, I would still split you up by grade, but then I'm taking the cluster. I'm taking all the 11th graders. That's going to be my cluster. Okay, and then systematic sampling is when you start with one member chosen at random and then use a rule, such as every third member of the population is, that's how I'm selecting my people. So if I'm looking at like a phone book, right, I'm gonna say, okay, I'm gonna pick every third person in the phone book. Or if I have a list, I'm gonna pick and I'm gonna have a rule. Or I'm gonna pick everyone that's wearing a blue shirt today. Okay, so anything that you have a rule for, that's going to be systematic, like a system. Convenience is just like it sounds. So convenient sampling is only choosing subjects that are in close proximity or are easy to get to. So if we were back in school, I would say that you guys would be my convenient sample because it's very convenient for me to ask you guys. You're in my class. Self-selected sampling is what we actually just talked about on the last, or 2 slides ago. It's when you are using a sample made up of volunteers. So it's whoever wants to take that survey can take it. So again, the 3 on the left are going to be the better way to take samples, and the 2 on the right are they have a very high risk of bias. Okay, so here's some examples again. So we have a study and then we have a sampling method. So the study is just giving an example, and then the sampling method is, okay, what type of sample is it? So starting with a randomly chosen ID number, every 5th student ID number was chosen and that student was asked to fill out a survey. So they have a rule there. So that's gonna be your systematic sampling because it has a rule. For B, we have a retailer put feedback cards at the front of its store. They got responses from 22% of their customers. So you don't have to take that feedback card. So that's going to be self-selected because they're volunteering to do it. And then for C, a city wants to know what % of people in the city own a dog or a cat. A city worker goes door to door in that neighborhood around City Hall to ask people about their pets. So this one is convenience because he's going to that neighborhood because it's very convenient for him. It's right there. Okay, so randomized experiments. So when we are doing experiments, again, we want them to be random. So when we do this experiment, you have an experimental group and you have a control group. So the experimental group is the one that receives the treatment and the control group is the one that does not. So a lot of times in like medical experiments, you have people taking actual medication and then you have people who get like a placebo medication, which is like a fake medication that doesn't do anything. So that way you get to see, okay, is this new medication actually working or is it not working? So there's our example there. Okay, so that is the end for Stats Day 2. So go ahead and check out your homework for this day.